What is protocol-oriented programming and what is the advantage of using it over objective-oriented programming? Well, the key word here is inheritance. I'm Alex from Rebeloper.com, and if you do like to learn about protocol-oriented programming, protocols in general, then go ahead and smash that like button and let's open up Xcode. Let's dive in. If you are using Swift for your iOS development, then you must know about protocols. Before we dive into it, let me remind you about the Dev Factory. It is at rebeloper.com/mentoring, a 60-minute Zoom call with me where you can ask me anything about Swift, Swift UI, or if you have a bug in your code, I can help you with that also. So again, it's at rebeloper.com/mentoring, and let's dive into today's topic, and that is protocols. So protocol-oriented programming. And let's see, what is protocol-oriented programming? Well, it is a mind blow. And this is kind of how protocol-oriented programming comes after object-oriented programming. So object-oriented paradigm, in that we focus on what the object is, and that's where inheritance comes in. So an object is a human, so Bob is inheriting from the human object. On the other hand, a protocol-oriented approach allows us to focus more on what an object can do. So let's say Bob can eat. So all of that stuff. And then we can use that can eat protocol onto other objects. But this is what we are going to learn. It's not that bad if you don't understand it till this point. So what is actually a protocol? Well, it is a list of methods and properties, as you will see later on in the hands-on example in Xcode. It's actually a blueprint that types can adopt or adhere or conform to. We have a lot of jargon that we do. I'm going to just use either adhere to or adapt. It's kind of the same thing. So think of it like a contract. It's not actual code that is instantiating something. It is just the contract. So what a type can do and what properties it can have. It is kind of these type, the type must have these, and it may have other conformance, like it can also adapt to other properties. We will see that later on, but this is the bare minimum that it must adopt. Okay, types can adopt protocols and implement the methods and properties from that protocol. So that is kind of the idea of having a contract that our type can adhere to. Protocols solve a lot of problems that object-oriented programming's inheritance has. So we will see that inheritance is quite good, but not that good. And the protocols solve a lot of things that object-oriented programming's inheritance has. Okay, so next up, we are going to talk about protocol extensions. What are they? Well, after setting up a protocol, we can extend it to add actual functionality. So this makes protocols really, really handy for inheritance. So it's kind of an alternative for inheritance for injecting functionality into a type. So you will see that also as the example in our Xcode project. So what are the main features, superpowers of protocols? Protocols can inherit protocols, so that's really nice. Types can adapt multiple protocols. I already talked about that. Protocols can represent different types of relationships. That's kind of the inheritance from object-oriented programming. Now, think of object-oriented programming's inheritance as an is-a. So, Bob is a human. So, those are two types, and the relationship between them is an is-a. Now, with protocol-oriented programming, we can think of it as a can-do. It's like capabilities. Bob can eat, and a human can walk, for example. Now, hands-on example, let's dive into the code. And what are we going to do inside the code? So, first of all, we are going to take a brief look at inheritance, but most probably you know about that. After that, we are going to create these protocols to support our types. And these will be actually the four types that we are going to create. Four classes actually: a rotary phone, a push button phone, you know, the one that you had to push but it's still a landline telephone, a non-smartphone like the pre-smartphone phones, like Nokia. I did have one at that stage. And of course we have finally a class called smartphone, which is kind of tappable. You don't have to push those actual physical buttons. And therefore we have kind of these protocols. We will see how, but the first two is a landline type of telephone, and the second, the last two are a cellular type of telephones. Of course, telephones may be landline or cellular, and there, furthermore, there will be a protocol, kind of a feature for these telephones. One is rotariable, so we can have rotary input. Then we have push buttonable, so we have push buttons input. And then we have touchable, which is kind of a touch input. As you can see, we have this able. You will see quite frequently that protocols are called like suffixed with able or ing. This is kind of how we can read out code really explanatory with protocols. Of course, landline and telephone are still protocols, you will see that, but touchable, for example, is a good readable name for our protocol. So let's dive into the code. What I have done here is just created a brand new Xcode project. This is vanilla, and created our protocol-oriented programming Swift file. So that is just it. Let me just have a little bit more time, space here, and then we are going to, I'm just going to add in a little inheritance reminder. So here we go. We have a telephone class which has two functions which are implemented. Yeah, here we are implementing the call and hang up functions, and the landline class is inheriting from the telephone class. Therefore, we can just go have our function call here. We can override it, of course, and so forth. You are most familiar with this. This is inheritance. But of course, we are going to talk about protocol-oriented programming today, not object-oriented programming. So let's kind of create our plan with protocol-oriented programming. So what we would do is create our first protocol. So let's do that. Let's just go protocol, and it will be named telephone. Okay, so that's our main protocol. This is kind of a contract that our classes will have. So it's just a requirement. It's like, okay, this telephone class has to have a phone number. So let's just add that, var phone number, and that is a string. And for properties, we have to set what type they are. So are they a getter and setter, or are they just getters? So we just go get set for phone number, because we should be able to get and set our phone number from that class that adheres to the telephone protocol. Okay, and let's just add in here two functions that call with two L's. And as you can see, we are not actually implementing the functions. This is kind of a blueprint. Whatever adheres to telephone will have to have a call function. So the other one, so that's our telephone protocol. Really, really nice. So let us adhere to our telephone protocol. So let's create our landline protocol. So yeah, first of all, we could just create a class here and call it landline and adhere to our telephone protocol, and therefore it will need to adhere to phone number, call, and hang up. And as you can see, Xcode is already complaining. So let's just add our protocol stubs. As you can see, phone number, call, and hang up will be needed to be implemented. Okay, so that's nice, but we can, and landline has no initializers. Let's just worry about initializers when I'm going to create an actual class that is needed in our example. In this case, I'm just going to show you that landline could be also a protocol. So that's our superpower number one, that protocols can inherit from protocols. Okay, so now our phone number is no longer needed, and let's hit Command B. So let's see what others. And it says protocol methods must not have bodies. So let's just, it moved away. Yes, let's just hit Command B. I think that this is what we are missing here. Okay, so let's hit Command B again. But actually, what I want to do here is not move our call and hang up into the landline protocol. I want to have a default implementation for that. So I will not even need to adhere to the call and hang up protocol, functions right over there. So that's where protocol instances comes really handy. So let's create an extension right over here on the telephone. So what I'm going to do is create these two functions, and I'm going to add in their implementations. So we are going to call right over here, and we are going to hang up right over here. So that can be done on the telephone extension. So therefore, we don't even need this right over here on the landline telephone protocol. How cool is that? Now, whenever you adhere to the landline, the hang up and the call will be automatically handled. It doesn't really matter what type you are using it. It could be a rotary phone, or it could be a touch phone, so touchable phone. Yeah, an iPhone or whatever. Okay, so that's a landline. Now let's create another one, another protocol, and that is cellular. So that would be our last two classes protocol. So let's create our protocol called cellular. Okay, and that is inheriting from telephone. So not inheriting really, it's adhering to telephone, because those are just some requirements. Okay, and let's just hit Command B, cellular, telephone. That's like a landline, so that is type corrective. But I also want to have a special protocol function for the cellular. So that would be send SMS. And as you can see, now the landline doesn't have to have send SMS, but whatever adheres to cellular will need to have a call. Of course, you can override it, but now here is implemented. But if we didn't implement it, then okay, that they would need to implement call, hang up, phone number, and send SMS. And you will see that when we are going to create our class. Okay. Finally, I want to have these kind of specialties for our phones, and the first one is rotariable. Now, this is kind of a tongue twister, but it is what it does. It has a rotary input. So let's create our protocol of rotariable. Okay, and this will have a function. So that's rotariable, and then we have push buttonable, which will have a function of button input. Okay, and finally we have touchable, which has a touch input. Now we have all the protocols in place. Let's create our classes. So first of all, we are going to create a rotary phone. So these are the types that adhere to our protocols. So this would be a class, and with protocols now you will actually see their flexibility. So the rotary phone will adhere to a landline, and it will also adhere to the rotariable. Okay, and it doesn't have to adhere to the telephone protocol, because landline already adheres to it. How cool is that? So of course we need to add in these stubs. So let's do that. First of all, we have our phone number from the telephone protocol, and then we have the rotary input from the rotariable. bear in mind that call and hang up, which are a requirement for telephone, are already handled in the extension of the telephone. Okay, so that's our rotary phone. Let's move on to our non-smartphone. So that would be our next class, and that's a non-smartphone. Let's just... Oh, no, that's not that's the third actually. We want to go with the push button. Come on, button phone. Okay, what about the push button phone? Well, it's still a landline, and but it's not rotaryable, it's push buttonable. So push buttonable. What this will bring into our class, let's just see what it will actually bring. That is our button input and our phone number. Now, I just forgot that this error just popped up. Class rotary phone has no initializers, or the same goes for our push button phone. It does not have a phone number initializer. So let's do that. So init phone number of type string, and then self dot phone number equals phone number, and that should make the error go away. Okay, and finally we are going to add that also here. Let's hit Command B again, and yes, build has succeeded. So we do need to have an initializer on that class for our phone number. Okay, now it's time to move on to our non-smartphone. Now, the interesting part with the non-smartphone and the push button phone is that they both have buttons, actual physical buttons. So they should adhere to the push buttonable. Now think of how you would do this with inheritance. It would be a mess. So let me just show you how easy it is with protocols. Let's create our class, and this time around it's not a landline, so it is cellular indeed, but it is a push buttonable. So push buttonable is adhered also. So let's just wait for our errors here, and as you can see now, because it's push a cellular, it needs to send an SMS, so you need to implement that. Also, it is push buttonable, so you do have a button input, and also because it's a telephone, so it adheres to the telephone protocol, we have the phone number, a getter and setter. So here I'm just adding the initializer for that phone number. Okay, and finally we are coming to our final class, and that is our smartphone. Okay, the smartphone will adopt the cellular and the touchable. So now we are going to have different implementations that are required. So let me just fix those. Of course, the send SMS because of the cellular, and the touch input of the touchable protocol. Let me just add in again our initializer so we don't have that error, and that's it. Now you can have these protocols work for you, and as you can see, inheritance is not really required. Now the cool part here is that all of these are actually of type, well, not type, of the protocol telephone. So if we wanted to, then we could just have an array of them, and they would fit in that telephone type, well, adhering to that protocol array, and we can do a lot of stuff. If, for example, if we want to override the call, it will automatically know which one it has the call, and it will just jump onto there. Also, the same goes for the SMS, so sending SMS. If it's a non-smartphone, it will know that it needs to adhere, well, it needs to go onto this function and execute this code. And if it is a smartphone, then it will automatically know that it needs to execute this code that is in the smartphone's send SMS protocol implementation. So there you have it. Protocol-oriented programming. It is a super useful in iOS development. Hope you are going to adopt it. Of course, you may stick to object-oriented programming or do both of them. I highly recommend moving from object-oriented inheritance to a protocol-based approach. Now, if you do like these types of videos, then go ahead and check out rebeloper.com/mentoring, where you can meet me on a 16-minute Zoom call where I can teach you about Swift or Swift UI on a 60-minute interval. Now, if you are having a bug in your code, then I am also available. Again, it's at rebeloper.com/mentoring. And there you have it. Protocol-oriented programming in Swift with the help of the super almighty protocol. And if you do like these types of videos, go ahead and subscribe to the channel. It helps a lot for the YouTube algorithm. And while you are at it, make sure to hit that notification bell to get notified of new videos on the channel as these ones. Go ahead and check them out. Also check out the channel right over here. I talk a lot about Swift, Swift UI in general. And as usual, I will see you in the next one.